We're going to use the given piecewise function to be able to find each of the following function values of f of -1, f of 5, and f of 3. Now, it's really critical that when we're working with piecewise functions, we understand the fact that where we send our inputs to will be multiple different kind of output rules. So in this case, we've got an output rule of -2 times your input, and then the other one is a third of your input plus 4. So the particular output rule that we use depends on the domain restrictions, and that's really important when we're evaluating functions, is that we understand those domain restrictions and where inputs are going to fit. So for this first one right here, we're going to tackle finding f of -1. So to find f of -1, we need to first of all recognize which part of the domain restriction does -1 actually lie in. And so what you want to check is you want to check these domain restrictions right here and check to see which one -1 satisfies. And it turns out that -1 is going to satisfy that first domain restriction because -1 is less than 3. It doesn't satisfy that one, of course. So because it satisfies that first domain restriction, then -1 is going to be sent to an output using that rule of f of x equals -2x. So really, you just do -2 times the input of -1, and then that gives you an answer of 2, and so that's going to be the value of f of -1. So conversely, if we chose this right here, 5 as an input, it turns out that if we check the domain restrictions, that this domain restriction right here will be satisfied when we have 5 as an input. So accordingly then, f of 5 is going to be determined by taking 1/3 of the input of 5 plus 4. So for this one, we're going to get 5/3 plus 4, and then to add those together, of course, you're going to need a common denominator. So let's multiply the 4 by 3 over 3, so we get the common denominator of 3 for both of these fractions. So now you're going to have 5/3 plus 12/3, and so that's going to give you a final output value of 17/3, corresponding to f of 5. And then finally, if we have f of 3, that we're going to try to evaluate right here, you'll have to check to see which statement 3 is going to satisfy, and it turns out that it doesn't work for the first one, it works for the second one since 3 is equal to 3. So then we'll have to use that rule, which is 1/3 of the input plus 4. Since a third of 3 is 1, then it's just 1 plus 4, which then gives us an output value there of 5. So I just want to show that these function values that we just found here can be also seen graphically. So this is the same function, so this f function we've used before when we've graphed and looked at domain restrictions. And so we've already graphed this, and so you're going to see on this graph the fact that f of -1 did equal 2 from our work up there is going to be represented on this graph right here, because you're going to see the point -1, 2. And then similarly, you're also going to recognize that we found f of 5 to be 17/3, which is the same as 5 plus 2/3. And so 5 does map to 5 and 2/3 up there. And then last of all, of course, we found f of 3 to be equal to 5. And so f of 3, yep, does equal 5, because that's the filled in dot. It doesn't map down to there because that's an open dot. So just recognizing that we can see all that sort of stuff graphically there as well. So down here, it says to use the given piecewise function v to find each of the following. So there's some kind of more fancy, dancy sort of stuff going on in what we're trying to find right here. So what we're trying to find right here is we're trying to find v of -5, and then what you'll see right here is it kind of looks like 3v8. So you can't times the 3 and the 8. We're not dealing with multiplication. So like this right here is to find v of 8, and then we're going to basically kind of triple it and subtract it away. So really you're going to have to find these kind of couple function values, v of -5 and v of 8, and then we'll just kind of do the operation stuff from there. So let me use some color so we can kind of keep this nicely organized. So v of -5 means you're going to have to substitute -5 into the function v. So it turns out that if you check the domain restrictions, -5 is going to satisfy that first thing right there. So that means to find v of -5, we're going to have to use that rule that v of -5 is going to be equal to of your input times itself 3 times, plus the input times itself twice. So in those parentheses, I'm going to put in the -5. So of course, you have to exponentiate before you can do that negative that's in front. So if you do -5 times -5 times -5, you're going to get -125 with the negative in front of it. And then plus, and then a -5 times a -5 is a 25. So we get plus a positive 25. And then, so this ends up being positive plus positive, which would be 150 is what we get for v of -5 right there. So then let's go ahead and try to find this right here, which is v of 8. So it turns out that 8 is going to be satisfying that domain restriction since 8 is greater than 4. So that means that v of 8 is going to be equal to, using that rule of 20 divided by 8 plus 3. You actually get a pretty nice decimal because it ends up going in 2.5 times plus 3. So you end up getting 5.5 there for v of 8. So finally, just to kind of simplify this expression all of the way then we just need to take v of -5, which is 150, minus 3 times v of 8, which we found to be 5.5. So it ends up being 150 minus 16.5, and that's going to give us a result there of 143, or not 143, 133.5 there for that particular kind of expression. And then over here, this is just taking v of -1 divided by v of 0. So you're going to have to figure out what those are separately. So if we start with v of -1, turns out that -1 is going to be satisfying that second domain restriction since it's between -5 and 0. So we're going to have to use that rule, which is -2 of your x minus 3. So -1 is our input. So following order of operations, -1 minus 3 is -4. And then we need to absolute value that now, which gives us +4. And then -2 times 4 gives us -8 would be that value. And then we'll also need to find v of 0. And it turns out that 0 is going to satisfy that right there since it's equal to 0. So we're going to have to use x minus 2, that quantity squared. So in the parentheses, 0 minus 2 is -2. And then -2 times itself is going to be a +4 is what we get for v of 0. So that means that this expression right here is going to boil down to taking v of -1, which is -8, divided by v of 0, which is 4, and that does simplify down to a value there of -2.